The situation presents a violation of the 2002 National Electrical Code, specifically concerning the use of a two-gang electrical box for range wiring. The range wiring consists of 3/8 American wire gauge conductors along with a bare copper ground wire. The problem lies in the interpretation and application of Section 314.16. A1 of the 2002 NEC, which addresses conductor grouping. This section stipulates that conductors belonging to the same circuit, which includes grounding and bonding conductors, should not be grouped together in a raceway, cable, or enclosure unless they are functionally associated. In the scenario provided, the 3/8 American wire gauge conductors are deemed not to be functionally associated. The term functionally associated is crucial here. It implies that the conductors must work together to achieve a specific electrical function. In the case of standard range wiring, where you have typically two hot conductors and a neutral conductor plus a ground, these conductors are not considered functionally associated according to the interpretation of this particular code section, especially when dealing with older code cycles like the 2002 NEC. The reasoning behind this interpretation is rooted in safety and the potential for electromagnetic interference or other electrical anomalies if conductors that are not directly related in function are bundled together. To rectify this violation and comply with the 2002 NEC, the conductors must be separated into different raceways or enclosures. There are a couple of practical ways to achieve this. Firstly, you could use a 3-gang electrical box instead of a 2-gang box. This provides separate compartments for each conductor, effectively isolating them. Secondly, you could run the conductors in separate conduits. This method involves encasing each conductor in its own protective tube or channel, ensuring that they are physically and electrically isolated from one another. It's important to consult with a qualified electrician or electrical inspector to determine the best course of action for a specific installation. They can assess the situation, take into account any local amendments or interpretations of the code, and recommend the most appropriate and compliant solution. Furthermore, always refer to the latest edition of the National Electrical Code and any applicable local codes to ensure that your wiring practices are up to date and in compliance with current regulations. The NEC is updated regularly to reflect advancements in electrical technology and to address emerging safety concerns. Stay informed about these changes is essential for ensuring the safety and reliability of electrical installations. In summary, a violation stems from the non-functional association of the 3/8 American wire gauge conductors in the range wiring, as interpreted by the 2002 NEC Section 314.16. A1. The solution involves separating these conductors into different enclosures or raceways, either by using a larger 3-gang box or by running them in separate conduits. Always consult with qualified professionals and refer to the latest codes to ensure compliance and safety. Here's a more detailed explanation breaking down the relevant parts of the National Electrical Code and the practical implications for the described scenario. We will consider other relevant factors that might influence the interpretation and application of the code. Firstly, let's revisit the specific section of the 2002 NEC that is at the heart of the issue. That is Section 314.16. A1. This section deals with conductor fill-in boxes and enclosures. The key phrase here is functionally associated. As previously mentioned, the 2002 NEC, in some interpretations, considers the conductors in standard range wiring not to be functionally associated. This is because, while they work together to power the range, they don't perform the same function in the same way that conductors within, say, a multi-wire branch circuit might. The code aims to prevent overcrowding of conductors within a box, which can lead to overheating, insulation damage, and other potential hazards. The number of conductors allowed in a box is determined by the box size, conductor size, and the presence of devices like switches or receptacles. However, Section 314.16. A1 adds another layer of complexity by introducing the concept of functional association. The interpretation of this concept can vary, and it's essential to understand how it's applied in a particular jurisdiction. Now, let's consider the practical implications of this violation. Using a 2-gang box when a 3-gang box or separate conduits are required can lead to several problems. Overcrowding conductors in a box can make it difficult to make proper connections. This can result in loose connections, which are a common cause of electrical fires. Overcrowding can also damage the insulation of the conductors, increasing the risk of short circuits and ground faults. Furthermore, an improperly wired box may not provide adequate protection for the conductors, making them more susceptible to physical damage. To correct the violation, as mentioned before, there are two main approaches. The first is to use a 3-gang box. This provides more space for the conductors and allows them to be separated more effectively. The second approach is to run the conductors in separate conduits. This provides the highest level of isolation and protection for the conductors. When choosing between these two approaches, several factors should be considered. The available space is one factor. If there is limited space in the wall or ceiling, it may be difficult to install a 3-gang box or run separate conduits. The cost is another factor. 3-gang boxes and conduits can be more expensive than 2-gang boxes. The complexity of the installation is also a factor. Running separate conduits can be more complex than installing a 3-gang box. Regardless of the approach chosen, it's essential to follow all applicable codes and standards. This includes using the correct size of conductors, making proper connections, and ensuring that the box is properly grounded. In addition to Section 314.16, 8.1, other sections of the NEC may also be relevant to this situation. For example, Section 310.15 deals with ampacity of conductors. This section specifies the maximum current that a conductor can carry safely. When wiring a range, it's essential to use conductors that are rated for the expected current draw of the range. Section 250 provides requirements for grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock and fire hazards. When wiring a range, it's important to ensure that the grounding system is properly installed and connected. It's also important to be aware of any local amendments to the NEC. Some jurisdictions may have adopted amendments to the NEC that are more stringent than the national code. It's essential to comply with all applicable codes and standards to ensure the safety and reliability of the electrical installation. Here are a few additional points to consider regarding the application of the 2002 NEC and the specific scenario of range wiring with 3/8 American wire gauge conductors in a 2-gang box. Considering the age of the code, 2002 NEC is a relatively old version of the National Electrical Code. Code requirements and interpretations can change significantly over time. While the fundamental principles of electrical safety remain constant, specific rules and their application can evolve. Therefore, relying solely on the 2002 NEC for current installations is not advisable. It is crucial to consult the latest edition of the NEC and any applicable local codes. Functional association revisited. The concept of functionally associated conductors is indeed subject to interpretation. In general, conductors are considered functionally associated if they are all part of the same circuit and are necessary for the proper operation of the connected equipment. For example, the hot, neutral, and ground conductors feeding a lighting fixture would typically be considered functionally associated. However, the interpretation becomes less clear when dealing with appliances like ranges, where the conductors might serve different functions within the appliance. Local jurisdictional interpretations. Electrical codes are often interpreted and enforced at the local level by electrical inspectors. These inspectors may have specific interpretations of code requirements that are based on local practices and conditions. It's essential to consult with the local electrical inspector to understand how they interpret Section 314.16, 8.1 and whether they consider the range conductors to be functionally associated in the described scenario. Conductor fill calculations. While the original question mentioned that the conductor fill calculations of 314.6 are met, it's important to verify these calculations carefully. The conductor fill calculation takes into account the number and size of conductors in the box, as well as the volume of the box. Even if the calculations appear to be met, the inspector may still object to the installation if they believe that the conductors are overcrowded or that the box is not suitable for the application. Practical considerations. In addition to code requirements, it's also important to consider practical aspects of the installation. A 2-gang box might simply be too small to accommodate 3/8 American wire gauge conductors and the necessary wiring connections safely and effectively. Overcrowding the box can make it difficult to make proper connections, which can lead to loose connections and potential hazards. Alternative wiring methods. If the use of a 2-gang box is deemed unacceptable, there are several alternative wiring methods that can be considered. One option, as mentioned before, is to use a 3-gang box. Another option is to install a larger junction box and extend the wiring from the junction box to the range using individual conduits or cables. This approach provides more space for the conductors and connections and allows for better separation of the conductors. Grounding considerations. A grounding conductor is an essential part of the range wiring system. It provides a path for fault current to flow back to the source, which helps to protect against electrical shock and fire hazards. It's important to ensure that the grounding conductor is properly sized and connected to the grounding system. The NEC specifies the minimum size of grounding conductors based on the size of the circuit conductors. Documentation and permits. Before starting any electrical work, it's important to obtain the necessary permits from the local building department. The permit process ensures that the work is inspected and complies with all applicable codes and standards. It's also a good idea to document the wiring installation with photographs and diagrams. This documentation can be helpful for future maintenance and troubleshooting. In conclusion, the question of whether using a 2-gang box for range wiring with 3/8 American wire gauge conductors is a violation of the 2002 NEC depends on several factors, including the interpretation of functional association, local jurisdictional requirements, and practical considerations. It's essential to consult with qualified professionals and refer to the latest codes to ensure compliance and safety. Always prioritize safety and follow best practices when performing electrical work. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable performing the work yourself. Here's a summary of key points presented in a structured manner for clarity. Firstly, the primary issue revolves around NEC section 314.16. A1 of the 2002 NEC, which governs conductor fill-in boxes and enclosures. Secondly, the core debate centers on the interpretation of functionally associated conductors and whether the 3/8 American wire gauge conductors and range wiring meet this criterion. Thirdly, local interpretations by electrical inspectors significantly influence the application of this code, varying across jurisdictions. Fourthly, even if conductor fill calculations seemingly comply with 314.6. B. An inspector may still disapprove due to perceived overcrowding or unsuitability of the box. Fifthly, alternative wiring methods, such as using a 3-gang box or running separate conduits from a larger junction box, offer compliant solutions. Sixthly, grounding considerations are paramount, necessitating proper sizing and connection of the grounding conductor according to NEC specifications. Seventhly, obtaining necessary permits from the local building department is crucial for ensuring code compliance and safety through inspections. Eighthly, documenting the wiring installation with photos and diagrams aids future maintenance and troubleshooting efforts. Ninthly, the age of the 2002 NEC necessitates consulting the latest edition and local codes for up-to-date requirements. Tenthly, prioritizing safety and consulting with qualified professionals are essential due to the inherent risks associated with electrical work. Let's elaborate further on the implications of using an outdated code like the 2002 NEC and why it's crucial to adhere to the most current version. Code revisions and updates. The National Electrical Code is revised and updated every 3 years to reflect advancements in electrical technology, address emerging safety concerns, and incorporate lessons learned from past incidents. Each revision brings changes to the code, some minor and some significant, that could affect how electrical systems are designed, installed, and maintained. Using an outdated code like the 2002 NEC can lead to several problems. Firstly, it can result in installations that are not as safe as they could be. Newer codes often include enhanced safety requirements that are designed to prevent electrical shock, fire, and other hazards. Secondly, it can result in installations that are not as efficient as they could be. Newer codes often include requirements for energy-efficient lighting, appliances, and other equipment. Thirdly, it can result in installations that are not compliant with current regulations. Building departments and electrical inspectors typically enforce the latest edition of the NEC, and using an outdated code can result in violations and costly rework. Specific changes since 2002. Since the 2002 NEC, there have been numerous changes to the code that are relevant to range wiring and conductor fill. Some of these changes include revisions to the requirements for conductor ampacity grounding and bonding, overcurrent protection, and box fill calculations. There have also been changes to the requirements for specific types of equipment, such as ranges, ovens, and cooktops. Impact on safety. Using the latest edition of the NEC is essential for ensuring the safety of electrical installations. The code is designed to protect people and property from electrical hazards, and adhering to its requirements is the best way to minimize the risk of electrical accidents. For example, newer codes may include requirements for arc fault circuit interrupters, which are designed to protect against fires caused by arcing fault. They may also include requirements for ground fault circuit interrupters, which are designed to protect against electrical shock. Consulting with professionals. Given the complexity of electrical codes and the potential for misinterpretation, it's always best to consult with qualified professionals when performing electrical work. Licensed electricians and electrical engineers are trained to understand and apply the NEC and other applicable codes. They can help to ensure that electrical installations are safe, efficient, and compliant with all applicable regulations. They can also provide guidance on selecting the appropriate wiring methods, equipment, and materials for specific applications. Continuing education. The electrical industry is constantly evolving, and it's important for electricians and other electrical professionals to stay up to date on the latest codes and technologies. Continuing education courses and seminars are available to help professionals maintain their knowledge and skills. These courses cover a wide range of topics, including code changes, new technologies, and best practices for electrical safety. In summary, while the 2002 NEC provides a foundation for understanding electrical wiring principles, it's crucial to adhere to the most current version of the code to ensure safety, efficiency, and compliance. Consulting with qualified professionals and staying informed about code changes are essential for responsible and effective electrical work.